All right, so real quick summary of the highlights that I gave students. CFU number 9, last chance to retake is today. CFU 10, 11, and 12 can all be retaken until Friday this week. However, students will not receive CFU 12 back until Wednesday. That's when retakes start. That's so that students that were absent last class have today and tomorrow to make up the original CFU number 12. Homeworks are on a little bit of an accelerated schedule because we're heading into winter break. So 32 and 33 are dead tomorrow. They were collected last week. 34 and 35 are due for the first time tomorrow, but they're dead on Friday. 36 and 37 are due for the first time on Friday. And then when you come back from winter break, I will give a 1 week period for people to turn in just those 2 homework assignments late if they'd like to. Okay. Again, this week we have 2 days of new material, although arguably it's not totally brand new. We've seen slope and rate of change before. We'll have 2 days of that, 2 days of review, and then a test on Friday. Once again, if students expect to not be here on Friday, really strongly encourage to take that test a day early. That way you're not coming back from winter break and immediately having to take a test. Okay. Students are already given a couple minutes to complete the multiplication at the top of page 23. And thanks to several different people, a couple typos on my part have been corrected. All right, moving on. So starting off with just a reminder of rate of change. The steepness of a line is referred to as slope or rise over run. That's often how it was referred to in Algebra 1, rise over run. The formula that allows you to compute slope is often referred to as the rate of change formula. Okay. Now, this formula, which allows you to compute slope, only requires 2 points. And what you're going to see that I do over and over and over again is I label those 2 points x1, y1 for the first point, x2, y2 for the second point. And that's because it organizes my thoughts when using the slope formula. Okay, the slope formula is nothing more than find the difference of the y values and put that on the top. Find the difference of the x values and put that on the bottom. And then just do the division. Now, as I said, we're going to do 2 problems where we're just practicing this formula, and then we'll move to applying it in context. Okay? So first real problem of the day says, use the left graph to plot the points 5, 2, which would go there, and 2, 7, which would go here. Okay? Then compute the slope between them. Now, you don't have to do this, but personally, I prefer to go ahead and draw the line connecting the 2 points. That way I can visualize the thing that I'm actually calculating, because that's what you're calculating. In fact, I'm going to make that blue just to recommend that you all do be in the habit of just drawing that line to visualize, okay, this is the thing I'm trying to calculate, the steepness of that slope. Now it says also use the right graph to plot points -3, -4, and 5, 3, and compute the slope between them. So again, I'll connect those points as well. Okay. Now I'm going to show work for both the slope calculation of this graph as well as the slope calculation of that graph. And before I do either of those, I'm going to label these points. So with the very first graph, I'm going to call this first point x1, y1, and I'm going to call the second point x2, y2. Again, that allows me to sort of organize my work because, again, the formula is up at the top. Take your second y value, subtract your first y value. So that's 7 minus 2. That's what's going to go on the top. Okay, right now we're calculating slope. On the bottom, I'm going to subtract the x values. So the second x value is 2, the first x value is 5, and 2 minus 5 is -3. It does not surprise me at all that the slope of that line on the left is negative, because if you track that line from left to right, it is decreasing. It is going down. So the slope should be negative. The opposite is true for the other one. If you scan this other segment from left to right, as you go from left to right, it is going up. It's increasing. So I would expect the second one that we're about to calculate to be a positive slope. Now, again, before I do that, and I'm going to use a different color just so that we're not getting the 2 graphs confused. Okay, actually, yeah, I'll use orange. Again, I'm going to call this x1, y1. I'm going to call this x2, y2. And these are the values that I'm going to use for my secondary calculation, the one for this other picture. So once again, the slope is nothing more than subtract the y value. So my second y value is a 3. My first y value is a -4. So you are going to end up with a double negative. On the top, you're going to have 3 minus a -4. And when you're subtracting a negative, you're really adding, so you end up with 7 on the top. Same exact thing is going to happen on the bottom. Bless you. Your second x value is a 5. Your first x value is a -3, so it's going to be 5 minus a -3. When you're subtracting a negative, you're really adding. And so you get a +8. So again, not shockingly, the first segment is decreasing, so I would expect the slope to be negative. The second segment is increasing, so I would expect the slope to be positive. And that's exactly what happened. Okay? Questions? All right, jump into the top of the next page. Again, a little bit more practice with slope. It says use the 2 graphs below to complete parts A and B that follow. Part A says compute the rate of change, which is slope, between the points shown on each graph below. Hint, it would help to first record the coordinate pairs. Okay. I'm going to record on the left image. Again, we're trying to calculate this slope, the steepness between those 2 points. And then eventually we'll do it on the other picture. But I'm going to call these 2 points my x1, y1, x2, y2 points. Okay. So I'll start with the very first one, the one in the lower left corner. I'm going to call that x1, y1. That's going to be the point 2, -3. That's the first point on that image. Okay, now the other point, the one that's higher up and on the right, I'm going to call that one my x2, y2 point. And that's located at 5, 6, it looks like. I'll make that a little bit smaller so it fits in the space. Okay, so those are the values that I'm going to use for the first image. Now, once again, following slope formula, on the top, you just subtract the y values. So it's going to be 6 minus a -3. 6 minus a -3 is really 6 plus 3, which is 9. On the bottom, I'm going to subtract the x values. So it's 5 minus 2. That's not a double negative, so I am legitimately subtracting. And 5 minus 2 is 3, and 9 divided by 3 can be simplified. If you can simplify, make sure you do. Okay? All right, now I want to give you all a chance to do the next one yourselves. So I'm going to write down the coordinate points, and then I'm going to give you all time to do the other set yourselves. So I want you to calculate this slope. Again, I'm going to record the coordinate pairs. I'm going to start with the point in the bottom left. I'm going to call that x1, y1. So x1, y1 is at the point -2, -2. That's the one in the bottom left. The one up here, which I'm going to call x2, y2, is located at what looks like 0, 4. Okay, and again, I'll shrink that down just so it fits the space. There we go. All right, take a minute and a half and go ahead and show the work, calculate the slope of that other segment in the second image. Go. All right, so here is the work. Okay, again, taking the y2, which is a 4, minus the y1, which is a -2, and 4 minus a -2 is really adding, so you get a 6. On the bottom, you've got 0 minus a -2. Again, double negative means you're really adding, and 6 divided by 2 is 3. So what do we notice about the slopes? I'm now talking about part B. What do we notice about the slopes? They're exactly the same. You got it. They have the exact same slope. Now, what this means, remember, slope calculates steepness. What this means is that they have the same exact steepness. They are equally steep over those 2 intervals. Just out of curiosity, does anyone recall the term from geometry when you have 2 lines that have the exact same steepness or slope? Starts with the letter P. Say, oh, I heard perpendicular. That's if they hit and make a 90-degree angle. But if they're going in the same direction, it's parallel is the word I'm looking for. So if this was, I'm going to write a bunch of stuff in purple. You don't need to write it down. If in geometry, this was point A and this was point B, so you have segment AB, and then this was point C and this was point D, so you have segment CD. In geometry, the symbol for parallel is 2 equal slanted lines. So in geometry, this purple statement up at the top of the screen will be read as segment AB is parallel to segment CD. Okay, and by the way, I can prove it. All I have to do is take this segment that connects A to B, drag it over here, and you'll see that it lines up very, very well with this other segment. They are indeed parallel. They're going in the exact same direction. Okay. All right. So that last question, by the way, comparing slopes, is something I purposely put in the note packet because it lends itself to the context problem we're about to do. Okay. In context problems dealing with slope, generally the idea is find this slope, use those calculations to make a decision, to make a comparison. Okay. So first context problem, and then I'm going to ask you all to do one yourselves. Here we go. Slow me down if you have questions, by the way. Like, interrupt me at any time. Based on the given chart, so before I keep reading, let me look at the chart. On the x-axis, it says year from 2000 to 2016. That has a bar for every single year. It says number of cell phone subscriptions in the US, and the y-axis is labeled number in millions. So the very first bar is telling me in the year 2000, there were 109 million cell phone subscriptions in the US. And by looking at the last bar, by 2016, there were 417 million cell phone subscriptions in the US. Okay. So part A says, on average, how many new cell phone subscriptions were added from 2000 to 2008? Show your work. So this is literally asking you to calculate the slope from the year 2000 to 2008. So to organize my thoughts, once again, the first thing I'm going to do is record this point. In the year 2000, there were 109 million subscriptions. This is my X1, Y1 point. Then they say, well, what was the slope? What was the change in 2008? So this is my other point. In the year 2008, there were 261 million subscriptions. That is my X2, Y2. So those are the numbers I'm going to use to respond to the first problem. Again, on the top, you have the difference of the Y values. So it's 261 minus 109 goes on the top. On the bottom, it's 2008 minus 2000, which is a difference of 8 years. So you end up with 152 divided by 8. And if you do 152 divided by 8, you get 19. Now, what's important is not only can you calculate that slope, but remember, I said this was a context problem. You have to understand what that 19 actually represents in this context. Okay? You good? So keep in mind, this graph is showing you how many more subscriptions there were every single year. And this is an average increase per year. So this is literally saying you got an average of 19 million extra subscriptions every year. Now, that doesn't guarantee it went up by 19 every year. For example, from 2000 to 2001, it went up by 20 million. From 2001 to 2002, it went up by 13 million. Now, from 2002 to 2003, it did go up by exactly 19 million. Okay, but every year it goes up by a slightly different amount, sometimes more, sometimes less. But the average increase was 19 million per year. Okay. Now, next question says, if the average rate of change you found in part A continued, how many cell phone subscriptions would you expect there to be in 2009? Anyone instruct me on what I'm supposed to do here? Imagine this was a test question on Friday. What would you do? All right, let me repeat what I just said for the recording. Okay. The number for 2019 is missing. We just found that the average increase per year was 19 million. And this question is saying, if the rate of change you just found, the 19 million per year, keeps going, well then how many cell phone subscriptions do you expect there to be in 2009? In other words, what do you think that number would be? Okay, and I think it was Ibuka who said it first, take the 261 that's in 2008 and add 19 to it. So if that rate of increase just continues for one more year, well, then I would predict 280 million cell phone subscriptions in the US in the year 2009. Now, we're going to repeat this exact same process one more time, but with a different pair of years. Part C says, on average, how many cell phone subscriptions were added from 2010 to 2019? Okay. Now, again, I would recommend creating your points. Okay. In 2010, I'm going to call this my X1, Y1 pair. Okay. In the year 2010, looking at the graph, there were 285 million subscriptions. That's right here. Now, my other point, my x2, y2 point, x2, y2 is for the year 2016. Okay, and in 2016, according to the graph, there were 417 cell phone subscriptions. Okay. So plugging in those numbers, again, you take the difference of the y values and put it on top. 417 minus 285 goes on the top. 2016 minus 2010 goes on the bottom. The bottom is easy. 2016 minus 2010, that's only a difference of 6 years. Top one, a little more ugly, but you end up with a difference of 132 million, which when you divide by 6, you end up with 22 million subscriptions per year. So here's what we've calculated in these two problems. Okay. The first problem, part A, was from 2000 to and we said that the average rate of change over that time period was about 19 million per year. In part C, we said, all right, let's start in 2010 and go to 2016. Now, it might be kind of hard to see, but can anyone see which of those lines is slightly more steep, green or purple? Purple. Purple is a tiny bit more steep. It's kind of hard to see because they're close, but I can prove it if I drag them to the same starting point. If I try to line them up, now you can really see, yeah, purple is a little bit more steep. And that makes sense because we found in the beginning, the average was 19 million per year. In the end, the average was 22 million per year. And that's what the last question on the page is asking. Can you make a comparison? It said, did 2000 to 2008, which is the green line, or 2010 to 2016, which is the purple line, have the greater increase in cell phone subscriptions? And what I would say is the 2010 to 2016. My explanation is it had the greater slope. One had a slope of 19, the other had a slope of 22. So the greater increase occurred during that second time period. Questions? So we only have one problem left. It's a problem I'm going to give you all a decent chunk of time to work ahead of me on. As I told you in the beginning of the period, I was going to give you one small hint, and that was just to help make sure you're reading the graph correctly. Okay, go ahead and turn the page. We're going to look at one more context problem. Okay, based on the chart below. Okay, let's make sure we know what we're looking at. It says total MCPS enrollment from the year 2007 to 2016, and it's number in thousands. So if I look at the very first point on this graph, what it's telling me is in the year 2007, there were approximately 138,000 students in MCPS. And then if you look at the very last point, it's saying in 2016, there were approximately 159,000 students in MCPS. Okay. So the one helpful hint I'm going to give you is you've got part A, which references a couple points. You're asked to find the slope. Part B does the same thing. And then part C is make a comparison. So for both part A and B, I would recommend as step one, record the points from the graph that you're actually going to be using, just as a way of organizing the math numbers you need. Okay. So I'm going to throw a 6-minute timer on the board. This is your time to complete this page. When that timer is up, I'll post the key, take questions, and believe it or not, that's the day. Okay. But get as far as you can. Don't spend 6 minutes stuck. If you need help, call Mr. Fee or myself over. Go. So I gave students 6 minutes to work ahead of me on this page. When we had about 2 minutes left, I revealed the full work for problem part A. Okay, so again, I recommended recording the points that you need from the graph before you actually do the work. One quick comment I want to make. If you decided to write out this full number, because remember it's in thousands, so if you wrote 146,000, no problem. Same thing here. If you actually wrote out the number in thousands, then here you would have gotten the number 2,000. There's nothing wrong with that. Okay, I didn't want to have to write all those extra zeros, so I just wrote the numbers as they appeared in the graph itself, remembering that these numbers represent number of thousands. So when I got the number 2, that's not saying on average MCPS went up by 2 students every year. It's on average MCPS went up by 2,000 students every year. So just be aware of that. Okay, if you did this for part B, you would have gotten a slightly higher number, 2.6, and that's what allows you to answer the last question. Okay, the period in which MCPS had the larger growth was 2011 to 2016, and the argument is because the slope was greater. Okay, so we are done. The being assigned today is homework number 36. Both 36 and 37 will be due this Friday. That's slightly accelerated, but again, it's because we're going into winter break. Okay, thanks for watching. Have a good one.